Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to learn the new subtopic 4.3 orbital overlapping. From Vesper theory, we are going in depth learning about the mechanism on how covalent bond is formed by using valence bond theory. Previously in chapter 2, you have learned the shape of orbital where we have spherical S, dumbbell P, and cloverleaf D. So according to valence bond theory, covalent bond between two atoms is formed through overlapping of atomic orbital. So it can be between the same orbital such as S and S orbital, P and P orbital, and even S and P orbital. In matriculation syllabus, we only cover for overlapping of orbital involving S and P. There are two modes of orbital overlapping. One is end-to-end, another one is side-to-side. Given an example of end-to-end orbital overlapping, which will form sigma bond. If you could see here, sigma bond can be formed between the same orbital or even different orbital. This sigma bond is said to have the highest electron density along the bond axis due to end-to-end orbital overlapping. So because of this, electrons will spend most of their time in here together, therefore they can rotate freely. So how do we identify sigma bond in the molecule? Basically, all single bond is considered as sigma bond. Next, we have an example of side-to-side orbital overlapping, which involves only p and p orbital. So pi bond will be formed from this mode of overlapping. It is a bond that its region is splitted into two. So these pi electrons will lie on both sides of the sigma bond like this, and due to these two regions, less interactions between electrons than that of this sigma bond. Hence, their rotations is restricted. So this pi bond will only exist if your molecule has multiple bonds. Once you have known the two modes of overlapping, we will look on the type of molecule you're going to encounter. So we have molecule with no central atom and has central atom. All molecules formed going to have covalent bond in it, hence there will always be orbital overlapping. But then, since our orbital is limited to only certain shapes, like spherical, dumbbell, and also cloverleaf, this will raise a concern for molecule that has central atom, which will share more than one electron with the neighboring atoms. Therefore, for central atom of a molecule, we're going to improvise the shape of orbital by doing a bit of hybridizations. Now let's recap what's in orbital overlapping before we proceed to specific example. First, it will involve only unpaired electrons, since sharing of electrons happen when unpaired electrons comes from one atom and combine with another atom. Overlapping of orbital will form two types of bond, sigma, which comes from the sigma electron, while pi bond comes from the pi electrons. And lastly, orbital overlapping will use only S or P orbital. No new orbital will be formed in this process. For the first example, we're going to look at molecule with only single bond. So we have hydrogen fluoride. So the Lewis structure of hydrogen fluoride suggests there's only one single bond formed from the sharing of electrons between hydrogen and fluorine. First, we need to draw the valence electrons orbital over diagram for each element present. Since hydrogen got 1 electron in its valence shell, so we have 1 electron in 1s orbital. As for fluorine, we have valence electronic configurations of 2s2 to p5. Therefore, we have 2 electrons in 2s orbital and 5 electrons in 2p orbital. So from this orbital diagram, we could see unpaired electron comes from both 1s orbital and 2p orbital of hydrogen and fluorine respectively. So only these orbital will do the overlapping. Don't bother with the other inner electrons since they're already happy to be there. Next, you need to show the overlapping by drawing the orbital involved. So 1s sphere with 1 unpaired electron will overlap with 1 unpaired electron in 2p orbital, therefore forming a sigma bond. Don't forget to write the element as well as the name of the orbital. Let's try molecule with multiple bonds. Lewis structure of N2 suggests there's triple bond formed in between two nitrogen atoms. So out of the 3 bonds formed, the first bond will form sigma bond, while the second and third bond will form pi bond. Since we have exactly the same atom, enough by drawing valence orbital diagram once. So nitrogen, with valence electronic configurations of 2s2, 2p3, will have 2 electron occupying 2s orbital and 3 electron occupying 2p orbital. So from this orbital diagram, we could see each nitrogen contributes 3 unpaired electrons, which makes a total of 3 bonds to be formed. Now, show the orbital overlapping, starting with the sigma bond. Since this electron is in 2p orbital, so please keep the shape as in dumbbell and make sure these orbital overlap with 1 unpaired electron each, like this. So we have nitrogen on the left, nitrogen on the right, overlap end to end, then we're going to form sigma bond. Next, we'll proceed to the other 2 bonds that form pi bond. So the pi bond still be contributed from the 2p orbital, but the way they overlap differs from this sigma bond, where they only overlap side to side. So make sure the alignment of your orbital tally with the one you want to overlap. If you have one of them tilt to the right, the other orbital on the neighboring atom also need to tilt a bit right. So both of these orbitals should carry different spin of ups and down. Hence, pi bond is formed when you cross them together like this, ups and down in here. So another overlapping should be drawn by tilting to the left, because we don't want them to collide with one another. Again, don't forget to write the name of this orbital and also the element. And don't forget to label these with pi as well. That's all for orbital overlapping. Stay tuned for the next video, which will cover for orbital hybridizations. Thank you.